read that? Good, because I don't want to make it any bigger. Cool, my name's Tim. So I'm going to be talking on how to ruin your life using shell scripts. This is, of course, one of those kind of ironic titles, right? That the point is that you can ruin your life with shell scripts, and by knowing how you can do it, you can hopefully avoid it. And so I'll be talking about kind of common types of problems that can kind of percolate for a while. So, you know, something breaks here, but it's a lot farther down the line that you find out about that. And so as a result, it's a lot longer to trace back to the root cause. So looking at problems like that. And then looking at kind of practices and habits that prevent them, and also looking a bit about at the background of like, why does this problem make sense? Why do we get ourselves into these sorts of problems? And so hopefully, once we have greater understanding, these problems become very shallow, and we kind of avoid them just by automatically understanding their risk. So the first section I'm going to have is titled "Wow, the Shell Does a Lot." And the reason why I created this segment is really helpful to have an understanding of how a shell takes the stuff we type on a line, and we can't define any more than just like a list of letters, and turns it into some action that we've asked it to do. And there's a bunch of steps that it goes through. Here's a little short list of those steps, right? I'm not going to cover them all. But I am going to cover kind of a simplified model. And so for that purpose, I've created this contrived command that you'll almost assuredly would never typed, but illustrates a lot of behaviors. And we're going to look at how this command goes from being a string to being something that gets executed by the shell. So the first stage, I will call it, is parsing. And there are 4 stages that I'm going to talk about. And these don't actually match up with this diagram. These are 4 stages that are a simplification of that, but a useful simplification, one that allows us to understand things. So, I'm leaving out details on purpose. The first step I call parsing. And what we're aiming to do, what the shell is aiming to do, is to break up this string into parts. Tokenize it might be something that people are aware of. And it's just going to do that very simply on white space here. All the white spaces, it's going to chunk it up into white spaces. The terminology around this is a little wonky. So these things are called words in the Bash documentation. So it breaks it up into words, but you might call it arguments or something like that. And when it does it, they're not all equal. So the first thing it gets out, that is the command, generally speaking, ignoring the edge case, which some of you know. And it's going to set that aside. It's going to put that in a separate box. And so here it is. So echo, the first thing, that got put into a separate box. And then the rest of this stuff, none of it's special. It just gets lumped into a big list. So I have a list with PWB, B, file, asterisk, this quoted string, this redirect operator, and this other thing. So it just makes a list of those things. Okay, so now we've parsed our text. And the command is now gone to the parsing stage. So the next thing it does is it processes it. And what it's trying to do is understand what's there and enrich it to its final form. Because a lot of these things are incomplete. For example, the $PWB, that's a put the variable here, not I want $PWB, I want the value of that. The asterisk says, I'm not looking for file asterisk, I'm looking for files that start with the word file. So what the shell is going to do is it's going to expand all of these. And it's actually going to go through this multiple times potentially. And so the variables, it's going to pop them out and resolve them, is what I'm going to say. So PWB, the current value of that is user. Home user. B, that's just a string. There's nothing to do here, so it's just going to copy it. File, this is interesting. So we have file asterisk. It's a globbing operator is the term when we're talking about shell commands where you're just specifying multiple files like this. And So what you're not actually saying is what file you're looking for. You're saying what files. What the files you're looking for look like, what their names look like. So in this case, there are actually 2 files that match that description. So this one thing actually comes out to 2. So this list has gotten longer, not just in length, but in the number of items. And that's important to pay attention to. We have this quoted thing. And nominally, the spaces would break things up, but the quotes say, no, 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 no. This is a thing, right? Where we're saying, by default, you know how to break things up, but occasionally I want to be specific. And that's what the quotes say. It says, no, 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 I'm treating all of this as one thing rather than letting you break it up for me. And so that string gets brought over, and the quotes are actually kept there because they're used later on by the shell to kind of denote how to handle this thing. The redirect operator goes over, and then this string actually, it detects that this is a variable, and it fills in that value. So now I would call this fully resolved. All of the things that are incomplete or ambiguous have been refined down to their final form. And so we've processed the string. But echo, it hasn't touched the command yet, and we're not going to touch that for a second. Okay, so now that we've processed things, and I copied that list up here so it's easier to follow along, we need to prepare to execute this command. And like I said, very simplified command. I'm not talking about pipes and things like that. But still, here's our command. We need to execute it. But there's some details. So it needs to create another process to run this command. Because when you run a command in the shell, it doesn't run it in that shell. The shell starts a new process, loads the command in there, kicks it off, and nominally waits for it to finish and then collects what's left. So in this case, it's going to create a new process, but we also did this. Notice that we have this little redirect operator. And it's going to say, I need to create a file for that redirection, because when I run that process, I need to store its output somewhere. So it goes ahead and it creates that file, and it hooks it up to the standard output file descriptor. I won't get into that, but essentially it tells that new process, hey, by the way, when you have any standard output, put it over here. So it sets that up. And then the other thing it does is it resolves the command. So the command before was just echo, but that actually doesn't refer to anything on the computer. It's a name, but it's not fully resolved. The echo command actually lives in the bin directory, so it fills in those details. It resolves the full command. And if you ever typed a bad command that says could not find command, that's when this couldn't be resolved, when it couldn't find something matching that. And the way it does that is it uses a special variable in your shell called path. I'll just show you if I do echo path. You can see that this is a list with these little semicolon separators, and this is where your shell is going to look to see if it can find the echo. So if it's in any of these directories, it'll find it and then fill it in. And it reads that left to right. So the first one that matches, that finds an echo in, it pastes that directory on the front of the command, and that's the command it's going to execute. So you can actually have multiple echoes. It'll choose the first one it finds. So it fills that in. So now we're really fully qualified. We're ready to execute. We know what we're going to run, and we know where we're going to put its output. And over here, you'll notice that we know this. And what is this list? Well, this list now is a list of arguments that are going to be fed into the command. And if anybody, who here has done C? Okay, argv, right? We know what that is. So your program, when it starts up, is given this special magical list, and it says, I don't know what you're going to do with it, but here's a list of things that my user wanted you to know. And that is this list. So this is the argument list. And one thing it's going to do is it's also going to strip off the quotes, because we're not passing a quote, a 1 space 2. We're passing a string. 1 space 2. That's it. That's a whole string. We don't need those quotes anymore. The quotes were there to protect that from being broken up and parsed by the algorithm as it moved through the processing and preparing stages. But now that it's ready to actually execute the command, it strips off those quote. And then we execute the command, which is like, duh, that's why we're here, that's what I intended to do all along. And when it starts up that command, it feeds it that argument list, those words that are left over, and then we get output, and it's a wonderful world. So now that we understand that, now that we've seen this, we have a good model to understand how this can go wrong. And so the first class of problems, and this is the biggest one I think, is variable chance of problems, because I like pithy titles. So these are problems you can have with variables. So for that, I'm actually just going to run a script, which I've got these problems illustrated with. And what this is this is going to follow, almost all my examples are going to follow this. I'm going to show a script, then I'll hit enter, then it'll show its output. Almost always. So there'll be some exceptions, but they'll make sense when I run into them. So I have a very simple script here. I'm running, we've all written scripts that kind of look like this. You've got the bash, the shebang, top as they call it. We set a variable to a value, and then we echo that value. It's kind of a pointless script, but go. Anybody surprised? Cool. Now let's make this a little more complicated. So we're doing the same thing, essentially. We're echoing the variable. But what I want to do, I have this prefix. I want to echo the word prefix suffix. I don't know what the prefix is. Here I set it to prefix, but I might set it to pizza or something else, right? And that's something that the user gets to choose. But then I have this suffix I want to add onto the end of it. So let's go ahead and try that. And we get no output. And who here is surprised by that? Cool, cool. And we all know what's going on here, right? Which is that our prefix and our suffix, this variable, when it's going through, it says, it's reading the string from left to right. It says $. Ooh, I know what to do here. I have a variable. What's it called? What's its name? And then it reads to the right until it runs into a letter that isn't valid for a variable. So we intended it to say the variable to be named A, but it says A-S-U-F-X, F-F-I-X. Oh, hey, I ran out of characters. That must be the whole name. So it thinks A suffix is actually the name. So we need to kind of separate that. And you can always use this, and I recommend people use it more often than they usually do. You can wrap a variable name in curly brackets. And what this is the same way quotes tell the shell, hey, starting here, I want all the things to be one thing until I hit another quote, closing quote. Don't break anything up between these two quotes. That's what you're saying here with these curly brackets is, this is the name. Here's where the name starts. Here's where the name ends. That is also a little bit of a simplification on what's going on in those curly brackets, as we'll see soon. So just bear with me. I understand this is not a complete example, but this describes, like, this is what the name is, use this. And so then when we run it, it knows where the name is, what the value is, it replaces that whole thing with the value, and we get the results we expect. So that's a common type of problem you could run into. Maybe when you're composing murals, for example, you could see that type of problem. So just keep that in mind. Okay, so now I'm going to get a little more complicated, and this is a Timism, right? You never really want to be turned into a verb, as in, oh no, it's been timmed. But this is a timmed. So I like to break up my shell scripts a bit. It's easier to test subchunks. It's easier to update them because you don't have to worry about the state. Global variables are pretty evil, and shell scripts are evil. And so it's a lot nicer if I break my stuff up into scripts. So I'll often have like a central script which kind of has the logic, and then it calls the other worker scripts to do the actual work. And so I have something like this, but I'm not really doing any work, I'm just printing to the screen. So I set A equal to 1, like we've seen before, and now I've updated the echo statement. I say outside A is A. And then I also have another script called inside.sh. And it pretty much does the same thing. It echoes the value of A. And when I run this, it doesn't work. And the reason why is because if you look inside the script, you see I didn't define a value for A. And so A is undefined. And how many people here are programmed in JavaScript? Yeah, okay. And now, raise your hand if you like type coercion. Yeah, this is, oh, you like type coercion?
Well, I'm a Ruby developer, so.
Yeah, okay. So type coercion is my bane in JavaScript, and this is a place where the shell does a similar thing, which is it says, well, A isn't actually defined, but that's not useful, so I'll just put in a blank for you. So if you use an undefined variable, the shell is happy to fill it in with nothing for you, which is not actually any different than an empty variable, right? A variable with nothing in it. This is a term in computer science called scope. And what we want to do is we want to pass that value A into inside. So inside has it. And so we can do that. There's a statement called export. So remember how I said a shell will collect and run a command for you. It launches a child process, loads the command in there, lets it run. Well, those child processes can do the same thing. So the shell ran test.sh, so created a new command, test.sh, and ran that. That, in turn, created a new command called inside.sh and ran that on this line. So a command is running another command. So there's an inheritance tree. There's a parent and there's a child. And in this case, the parent has a child who has a child. And so we can control how values get passed up to the children. How variables get passed up to the children, and we do that with the export statement. So we can say, hey, by the way, this value, A, while I'm at it, could you make sure all of my kids get that too? So it inherits that value. And so when we run the script now, we have exported A, we've marked A in a way that allows it to be inherited. I can tell you how, but we are short on time. So ask me after. And now this works. Outside A is equal to 1, inside A is equal to 1. So we've taken care of that part. Now, you can actually do that a little more tersely. You can go ahead and put it right on one line. So if you know right up front that you're going to export it, it'll just work. Okay, so now we've gone through it. But there's some other ways you can do this. One thing you can do is you can make the shell more insistent that if you pass it a bad variable, that it won't accept that for an answer. It won't just fill it in. And so that's what I'm doing here. So this looks about the same. I'm running this script, but then I'm executing this command to show the exec code of that script. And remember, when we're running shell scripts, 0 means everything happened great. Anything other than 0 means something went wrong. Except where that isn't true, but moving on. So inside is now a little different. Inside, I'm printing the value of A. And then I'm printing, you never see this, because you won't see that. But you recognize these curly brackets, right? These are familiar. But I'm doing something a little different inside. So this part, this looks like we've been doing before. But now I've got this colon question mark, you need to set A. So what's going on? Well, the thing to notice is this colon question mark. So the term is parameter expansion. This is a parameter expansion operator. This can be a bit confusing because I have been using the word variable up till now. So we're expanding variables, or are they parameters? You ask. So this is a parameter expansion, and remember that. There's a lot of these. They do lots of neat things. Google for them. Google bash parameter expansion. Don't remember them. It's annoying. There's a long list and they're cryptic. But they're very helpful when you need them. And what this one says is, colon question mark says, hey, If that variable to my left, if A is undefined or blank, that's a problem. Stop right now. Raise an error and print this message. So when I go ahead and I run this code, it doesn't persist. It doesn't persist with a null value or an undefined value. It just stops immediately and says, hey, you did something wrong. Go fix it. I will keep going. And nicely, it also prints a very helpful message. So in line 2, it says, this variable A, oh, there's A. Oh, hey, I need to set A. Oh, okay. I forgot. I need to have an export A. So it gives you a very helpful message. It stops before you get into trouble. For example, you don't start running with empty parameter lists, the commands that might delete data or something like that. You get a clear message. So this can really improve your script. But it is a little fiddly because it means that everywhere you use a variable, you've got to put some helpful text around it, right? You got to say, hey, when I use it right here, be noisy and make sure that the user knows that they've done something wrong. So there's another way to get similar functionality, and this is by using set-u. So these scripts look very similar, right? The old script and the new script look very similar. Test is running inside, but on the inside, I'm just using that same $A that I was using before, but I've added this line set -u. And what does set do? Well, set is a way of configuring the shell. So by using the set command, you can tweak how the shell behaves and how it works on things. So it's kind of like a settings switch. You can turn settings on and off or change values. And so what I'm going to do here is I'm going to use the -u switch. So you can say set -u, which communicates with bash and says, hey bash, while you're executing this script, undefined variables, don't be helpful. Those are a problem. Those are an error. Stop. So it makes it more insistent, that it makes it more picky when it runs into situations in which you haven't actually clearly defined what you want. And so in this case, undefined variables. So if I run this, you'll see that it stops on line 3. So 1, 2, 3. So it stops on that line. It says A. Oh, there's the A. And it says unbound variable. And we like to keep our variables in bondage. No. What it's saying when it says unbound variable is that I have a variable name, but I don't have any value attached to it or bonded to it. So it's unbound. It's not bonded to any value, or bounded to any value. And so that's what that's saying. So it means essentially, hey, stupid, set A to something. But that's what that message means. And then you can see it also sets a return code. So our script ends with an error, and it gives us, again, a pretty clear message on what went wrong. Hey, you're trying to use something that you haven't defined. So that doesn't cover all cases. Sometimes there's sensible defaults. Maybe you want the user to be able to define something, but if they don't, you know what to do. So this is just one other parameter expansion, the :-, and this is the default operator. That's what I see usually used with this. So it says if A is undefined or it is empty, it doesn't have any value, use this instead. Use this in its place. It doesn't change the value of A. It just changes the value that's realized. So it says, well, fill this in if you don't have anything else. And so when we run this script, you see the not set value is displayed and passes. It's not an error. So you can use this to allow your script to have configurability, but run with sensible defaults. You don't need some if statement to say, well, if the user said something, then I can, this will do it for you.
How universal are these scripts? Bash, C shell, K shell?
I haven't checked C shell. I believe they come from the Born universe. I must confess, all my examples have been in bash because, well, I mean,
Who uses anything else?
yes, Z shell is definitely intriguing, but it is a Born compatible shell, and I have been looking at some Pythonic shells, but generally this will hold true in the bash ecosystem. I'm not positive though. You can, if you want, you can check parameter expansions in Born shell and see if that holds true. I know the curly brackets work in Born shell. I don't know if all the various types of parameter expansions do. Okay, so we've got another example here, and this one does something surprising. Now, quick show of hands. Who was surprised by that output? Yeah. Now, another show of hands. What happened? Do you know what happened? Do you think?
White space collapse.
Why was the white space collapsed?
Hold on.
Okay. So, you remember how before I was talking about how the shell runs through, it parses, it processes the line, and then it prepares to execute the process and executes it. So this is something that happens in the process stage, where it's taking that line and it's refining it to the final values, filling in all the blanks, right? And so what's happening here is when $sign is realized, when it's filled in, what you've got is a line with A, space, 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 B, space, 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 C. And the shell says, hold on, I just expanded something, and it looks like there's actually 3 things here. And why is it doing this? Why does it behave in this way? Well, because it would be a real pain in the butt if it didn't. And how many people have seen a shell script where you have something like command space, $options space? That $options, you can imagine that if it didn't do this breaking up of the command over in that line after it pasted it in, that $options would be passed the command as like a single monolithic string, which isn't what we wanted. So if we had an option of -A-B, we want, so we have a string with quote -A-B, close quote. We want those 2 options to be passed the command that we're executing. But if it was, it was held together, then that wouldn't work right. So the shell will iterate over that line and refine it and refine it and refine it over and over until it finds nothing that it can reduce down anymore. Does that make sense? So that process line might be run a few times. And that's what's happening here. So this string became a command line with echo A, a bunch of space B, a bunch of space C, and then the shell said, oh, hold on, there's some more processing I can do here. I see I can break this up some more, and it did. And so then what echo saw was a little different. So here I'm using the set-x option to the shell, and like set-u turns on an option to disable undefined variables. Set-x says, after you've processed the line, but before you start preparing to execute it, just show me what you did. Show me what got filled in. And so when we do this, we can see what happened. It filled in 3 values. And then echo said, okay, well, I've got 3 things that were passed to me. I'm going to echo the first one is space, the second one is space, the third one is space. And so how can we keep these spaces from being interpreted by the shell? We can quote them. Not with single quotes, but with double quotes. And so now when we run it with double quotes, it works. This is not surprising, right? People have double quoted spaces for a while now. But that's why you need to double quote them. That's what's happening. But there's also another way. So there is something called the IFS. And this is not another government agency. This stands for Internal Field Separator. So when the shell expands a variable, it examines that variable to see if there are any other expansions it can do on that variable. And just like at the beginning, it parsed a line based on white space, Down here, it's going to now process a variable expansion based on IFS. And what IFS does is, well, actually, here, I'll show you the output. So IFS just starts out with, IFS is defined as a space, a tab, and a new line. And so what it does is it says, any of those characters, space, tab, or new line, those define separations in the variable, things that you can break up on. So break up on a space, tab, or a new line. So what I've done with this script here is, and this is a habit, I didn't need to do it for the example, but I'm doing it because it's a good habit, is first I back up the value of IFS, and then I'm changing my IFS. So you saw down here, this is the old IFS, and this is how I printed the IFS because it's a little weird showing it on the screen. So it's kind of a weird way of printing it, but here's the old value for IFS, so with space, tab, and new line, and I'm setting it to new line and tab. I'm taking the space away, and then I'm going to echo that variable, and then I'm going to reset the IFS. And you see that now that the shell has been told, hey, space is no longer a field separator, it doesn't use it as a field separator. So this takes care of a lot of problems. And how many people have used and reset IFS before? Yeah. How many of you have done this because you had a file with a space in the name? Only one of you, really? Okay. I'm curious what the others are.
Weird double quotes. Yeah,
Double quotes?
processing weird files.
Yep. Okay, so that's another way to deal with problems. So here's I forget what this example is about, actually. Oh yeah. This is, so I have just such a file right here. I have a file with the space in the name. If you're running on a Mac, or you're running on a Windows box with Cygwin, or with the Ubuntu shell now, you're going to run into this a lot. Or if you're running with a GUI desktop, you might run into this. So normally, actually, crap. Let me cancel my examples and jump through. Broke my demo. So if I go ahead and do a command like this, how many people have done a command that looks something like this? Like, go through this directory and tarball all the stuff you find, right? You've probably done that. Yeah. And you've gotten this output. No, there's only one file in that directory. And that's because, of course, the IFS rules allowed that to be split. So once that variable got expanded into file actually became two variables. And so if you reset the IFS to get rid of the space, that goes away. Now, this really isn't the best way to do this, but it's reasonably good. So there's some other ways, like playing around with Globby operators and so forth, which I'll talk about a little bit in a second. Okay, how am I doing for time? Okay, so let's go back to the slides. So the next section I'm going to talk about is, what's that file name? And so let's look at some problems you can run into file names. I already alluded to it with that file space one, but let's make this even worse. Let's look at this directory of files. Yeah, this is messy, but this is real world, folks. This is what happens. And so we've got some files here that are kind of hard to deal with. We've got a file with a space in its name at the beginning. We've got a file which looks like a command line option. I wonder what that's going to do. I've got a file with a space in the middle. I've got a file with an asterisk in its name. And I actually have a file which looks pretty normal. That's weird. So if I run this loop on this, we're going to get some nasty output, right? It can, like file one, it says there's no such thing as file one. Well, that's because you were asking for file one, not space file one, right? So that parsing algorithm and that or was the processing algorithm, it's crunching those spaces. It says, well, this is a field separator, but there's no field on the left given the space. Nope, that actually is significant. With the dash, ls thinks you're passing the command line option. A bad one, but a command line option. It says, hey, so you can imagine trying to delete this. Trying to do RM on a file that has a dash in the name, very hard to do. Actually, it isn't, but I'll show you the secret in a second. This one, file 3, it says there's no such thing as file, and I don't know why it's in reverse order, and there's no such thing as 3, so it chopped it up into 2 names, thought it was 2 names. And then this file asterisk, you see, it lists part of the directory. I'm not sure why it doesn't list the whole directory. Oh yeah, because these things don't start with the word file. So it lists file 3, file, and file. So you get that list. And then file 5 is actually the only name that's same. So you get a doubled up one at the bottom. So some serious problems. So how can we deal with this? Well, the first thing is let's use the globbing operator. And this globbing operator, just those globs actually do match spaces. So it's pretty solid. What gets stuck in the file will be a full file name. We're not going to be going through any of the interfield separators. Those don't get applied to a file name that's returned by a globbing operator. Okay, and then we're also going to quote the file name because that'll keep that variable expansion thing from going wonky. So that's a lot better. We preserved the space here, we preserved the space at the beginning of the line. The asterisk didn't cause us any problems. That actually took care of most of our issues. But we still have one problem, which is that we passed a bad option to file. And so we can fix that by just adding a double dash. Not all commands support this, but most commands that operate on files do, where they'll say that, hey, after you've specified all your options to me, you can put a trailing double dash, which lets me know to no longer honor dashes, to no longer see them as options for me. They're just characters now. They're not instructions to, they're not instructions on like switches I need to throw or something like that. And so when we do that, we now get a clean list. So if you want to delete a file that starts with a dash, rm space dash dash space file name. It tells rm, hey, after this point, don't interpret anything as an option. So if you have a file name dash rf, you're okay. Okay, so that is kind of ways you can screw it up with file names. Now let's talk about ways you can fail a test. And of course, that's tongue-in-cheek, that's the test command. So these are fun. I like these. So, quick question. How many people think that the word big will be printed on the screen? Raise your hand. How many people do you think, or how many people think that the word small will be printed on the screen? Okay. What happened? So, this is a little gotcha, and I was talking about this with some people about an hour ago. And that is because of this. Shell, I don't love it as much as I once did. So this is a test operator, right? These straight square brackets. It's like, do something in here and then return a 0 if it's true and a 1 if it's false. Which is backwards from everything else, but moving on. But due to that, like just sum this stuff up as some number, a 0 or 1. Okay, so we get that, so strip off the brackets. So what we're saying is take this A, and if this A is bigger than 1, do something. So we have a variable, a comparator, and another variable, or another value in this case. So this gets turned into a value, so we can just replace it with a 0. So 0 is greater than 1. Okay, but the problem here is that this operator operates on strings. It operates on text. You can say apple is less than banana, which you can't do with numbers. So this is a string comparator. And in the shell, you have string comparators and you have numeric comparators. And they are not the same thing. And so if we turn this into a numeric comparison, we get the result we expect. So there's an equivalent to all of the numeric, all the string comparators, there's an equivalent numeric and vice versa. So there is a GT stands for greater than. If you have a double equals, that's the two strings are equal. You have dash Q for equal, less than, all these things, they're all kind of simplifications of that, the names that we would speak out if we were looking at the comparators. So the thing to remember is that if you're comparing numbers, use the comparators that are made of letters. If you're comparing letters, use comparators that look like they're made for numbers.
What about comparing integers to like a real number?
You could do like, here, so 35 is equal to, sorry, I'm doing, what type of comparison do you want me to do?
Numeric.
Numeric, okay.
Integer versus float.
Okay. Equals, and what it'll say is that. So it says, you fed me a string.
No, I guess what I meant to say is, if you've got two variables that are numeric, one is an integer and one is a float.
So something like this.
Yeah, exactly.
Yeah, again, same thing. It's an integer comparator. So numeric comparators in the shell. I think the $paren thing might be able to do floating. I'm not positive. I don't do math in the shell very often because I just don't need to.
So the EQ, the LT, and the GT are for integer.
Exactly. So, so just remember, it's always backwards. If you're comparing numbers, use strings. If you're comparing strings, use the things that look like they're made for numbers. Okay, so here's another example. And how many people are like, yeah, that was me? Right? You made this mistake, right? Almost everybody in here has made this mistake at some point. So B is set to nothing, and when I do this comparison, I get this unary operator expected. You'd think that, these people were smart. They could come up with like clear error messages, right? Right? Like, you could just say, hey, idiot, you left a value out. But what it says, no, it doesn't say that. It says, hey, this is a binary operator, but you only gave me one value. So you should be using a different operator. And you're like, but I gave you B. So what's happening here? So let's go back to our set X. Let's see what happens to the command line after it's been processed. And so we set B to a blank. And then here's our comparison. And where did the value of B go? Well, B was blank, so the shell said, well, it's blank, I'll just skip that. I don't need to put anything there. So if you have an undefined variable, it comes up as blank. Or if you have a variable which is blank, both of those cases, it'll omit it. And so as a result, what this equal command is expecting is a value to the left and a value to the right. And what it got was a value to the right. So we need to tell the shell, there's a spot here. I don't care what's in it, but there's a spot here. And so we can use double quotes for that. And so when we run this, you see that it's holding nothing. It says, and over here is nothing. No, there's something that's nothing. Something's nothing's something, right? Yeah, you try to explain null to people. But, but it keeps it around, so as a result, this operator doesn't fail. Now, it also happens to not be true, but it doesn't fail. It doesn't give us an error. So let's go with another scenario.
Out of curiosity, because I can't remember, if B was a string with just spaces in it?
I thought you were going to ask that. Let's try that. I forget.
Yeah, I have no memory if it'll treat that as
Oh, yeah.
like
So
a build value
B
too.
equals two spaces. Let's make it chunky.
Yeah.
Okay, so $B equals G. And then echo true. So those spaces go away.
Well, quote B. Quote B. What happens? If you quote B, what happens?
Oh, it'll work.
Yeah. But is it true? I guess.
Yeah, if you double quote B, right? Absolutely positive.
Yeah.
It's not true. Yeah, so I'll change that to a more. So now it works. And actually I can do a set dash x and see it in action. You want to turn set x off, just do +x. Okay, so back to the examples. So I have a variable with a space in it, and I'm doing that same thing, except now this time I get too many arguments. This is an old joke, right? I forget how the joke goes, but it's something like, you know, why did I divorce my wife, $wife, too many arguments. But anyhow, so we've got B, but we've got a space in it. So when the shell processed it, it said, oh, there's a space. I've got an IFS. I break things up. And so now you've got value, comparator operator, value. And it's expecting 2 values, but it got 3. So again, double quotes for the rescue. So just remember that. Okay, another way to do this, very common, you see this in a lot of scripts, is where you just make sure that this is never blank. And what you can do is you can just add an X in front of it. Usually it's an X. And so then when it executes it, it's like, well, if it's the degenerate case where I don't have a value, at least I've got X, so it holds the spot. And since I've got an X on both sides, it doesn't actually change the meaning of the expression in any way. So that's another way to do it. The double quotes is probably better because if you had a space in your variable name, then it would group up on that space, whereas the X wouldn't do that.
And so I think the double square brackets helps out with some of those cases as well. I don't know if you've ever seen incorporated.
No, I have seen the double square brackets, and I didn't dig into that.
Okay, yeah, it's supposed to take care of some of the space issues, right? Like
Yeah, and I should have looked into that, but I'm already running close to it, so thank you. And so yeah, double square brackets behave a little differently. They're also shell specific; they're not as generic. But okay. So the next thing is redirecting your issues. Did you have a question? No. Okay. Redirecting your issues. So things that you can screw up with file redirection. And this is pretty quick, and might be the hardest example to explain. So we all are familiar with file redirection. I'm taking some string, I'm sticking it in a file, and I'm adding the contents. That's kind of the basic pattern in these examples. So let's do something a little different. Let's do something odd. Let's cat the file into itself. Well, I mean, if I take a file and put it in the file, it's the same thing, right? Like it doesn't change the content, right? But we get nothing out. So, quick show of hands, who found this surprising? Okay, cool, so we've all made that mistake. Quick show of hands, who thinks they know why this happened? Oh, wow. Okay, I'm going to be teaching a lot of people. Okay, so how do we get into this situation? Here's a less contrived example. Here's something I really have done. I've got something, but I want to tweak it. I want to change hello world to goodbye world because I'm morose. But I can't do it. Instead, I just delete it all. And you've probably done this, like a log file. oh, I'm looking for a count of how many times a certain error occurred. First thing you do, strip off all the timestamps. Okay, now I've stripped off all the timestamps. Now sort it and count it, right? Well, you're going to want to do something like this, and you're immediately blow away that log file. So if your command supports it, sed does. It has an in-place editor -I, which says, don't blow away the file. You know what you're doing. Just edit it in place. So if you've got that, use it. Perl hi, Perl -p-i space -e. I think it is how it goes. Or no, -p space -ie, I believe it is. Will allow you to do similar things if you're a Perl person. And so this now works, right? But that's kind of relying on sed. What if we're not so lucky? What if we're using TR? TR is not very sophisticated. So I have this text called hello world, and I want to put it into uppercase. And so I've got this TR statement here that's putting it into uppercase. And I'm going to run it through a pipe and then dump it into the file. But what I've done here is I said, okay, what I'm going to do is I'm going to make a temporary file. I'm going to put it in there, and then I'll replace the original file with a temporary file. And so to make that temporary file, I'm using this command called make temp. So it generates a randomly generated temporary file. And I set temp file equal to that value, so that's the file name of the random file that was generated. I'll print that file name on the screen. I'll go use that file, and then I'll take that file and I'll write over, you notice I quoted the file name, write over the message file, and then I'll show the file contents. Okay, let's run. And here's that temp file, so you can see it's pretty random. You're not going to guess that. And then you know, it ran through all these steps. You can see I got the result I wanted. I changed the file and updated it to uppercase. But there is a side effect. What if I set some ownership and permissions on the file? They changed. So here I set some permissions on the file, and then I ran through that process pretty much the same way I did before. But what ends up happening is temp message. It isn't the file I started with. I have a new file, temp file. And so when I do the move command, what it did was it actually deleted the old file and took the new file and renamed it into location. So as a result, the permissions of that new file replaced the permissions of the old file. And this can cause other problems. For example, if you're editing a log while something's writing to it and other things, I won't get into all of that type of stuff. LSOF, pipe rep deleted. And so this is a problem. So this is a little habit I picked up. Don't move the file, cap the file. So what that'll do is that'll replace the file in place. So it's not replacing the file, it's just replacing the contents of the file with the contents. So now you don't have to worry about this at all. You don't need to know about it. Just cap the contents in. You can do this with a binary too. Like you can do this with all sorts of things. Just get in this habit, and now the permissions are preserved. You don't have to worry about that. And then you just remove the temp file. So now permissions are preserved. So this saves you from certain types of problems you can have with that. Okay, so the last is a collection of examples. I'm doing 4 things. So I'm running this, or 5 things. I'm running a command ls missing, which no such file or directory. So we're going to get an error message from that. Then I want to store that error message in a log file. But, and you'll see a little reference here. Number 1 is, or blank, means standard output, standard out. And number 2 means standard error. So this number here refers to, here there's an implicit 1. You can't see it. But over here, I'm being explicit. I'm saying, no, don't use 1, use 2. So in other words, and when this ls command runs, take its error output, the output it's sent to standard output, and put it in the log file. And in these cases, I'll show it. On this third line, I'm going to do something a little different. I am going to redirect standard error to an and one file. Well, no, actually, what this and one says is redirect standard error to wherever standard out is going right now. And then I'm going to go ahead and redirect standard out to a log file. So this is what I want. I want my errors and my normal messages to be in this log file. Sensible, right? We've done this before. Today, I'm also going to do it the other way around. I'm going to redirect standard output first, and then I'm going to redirect standard error. And these are the two that I want you to notice. These are the things. So my question is there a difference between these two? Is the content of the log file going to be different? Show of hands. Who thinks it's going to be different? Everybody thinks these are going to be the same? You think these are going to be the same? Show your hand. I want answers. Show your hand if you think they're going to be the same.
No.
Cool. That's reasonable. It's reasonable. I mean, order shouldn't matter here, right? Okay, so let's see what actually happens. Okay, up here, we've got the error message, right? We expected that. Now I'm going to go ahead and I'm going to send that to the log file. But when I cat that log file, so the error message was printed on the screen. It didn't make it to the log file, even though I said redirect the output. That's because the error message was printed on standard error. It wasn't printed in the standard output stream. And Unix machines do this. You have two ways of outputting. You can output an error, you can output regular old text. And they're different. So you have to capture them both if you want to get both. So here I'm capturing the errors. I'm saying, give me the errors and put them in the log file. And now we can see that, that I don't have any message on the screen. I see that if I cat the log file, there's the contents. There's that line after the cat statement. That was what was in the log file. Does that make sense? Okay. So now we're doing this in the order where I do my redirect my standard error, and then I do my redirect of standard out. And we see, again, we have the same problem. The errors are still being displayed on the screen. The log file is empty. So why is that the case? Well, let's just look at the second example. I'm redirecting standard output, and then I'm redirecting standard error. And now I'm getting what I expect, which is when I cat the log file, I actually see the error in the log file. So the question is why is this difference? Why is the order right here important? And this is why. And if you listened carefully, you might have noticed certain word choices earlier. So 2 is here. I want 2 to be redirected to point at wherever 1 is pointed. I'm not pointing 2 to 1. What I'm doing is I'm saying wherever the standard output, whatever file or target standard output is currently using, make me use that target too. Then I change the target of standard output. So what I've essentially done is back up the value of standard output's target, and then I change the standard output. So if you do it in reverse order, what now I'm saying is change standard output, and by the way, by default, standard error, standard output, they both go to your terminal. They both go to the screen by default. So in this case, it would say, take this thing that's going to the screen, point it at the screen. Take this thing that's going to the screen, point it at a file. Here now what I'm saying is take this thing that's pointing at the screen, point it at the file, take this thing and point it at wherever this is pointed, which is now a file. Does that make sense? Do you get it? That's a funny gotcha. So just remember that and 1, that is not a reference. That is a copy by value. And so if you remember that copies by value. So if the value is currently terminal, it will copy the value terminal. Okay. So how am I doing? Oh, I'm running out of time. Cool. Okay, so some good habits. Let's talk about some good habits that you should have. And this is a fairly short list. The first thing is always, pretty much always use set-u. You just never want to use a variable you haven't set a value for. I mean, that's just silly. Now, one problem that can happen is if you call a script that depends on undefined variables, or actually just uses them but doesn't get into trouble using them, this will break that script, because what ends up happening is you set -u, you call something else, and then it has an undefined variable, and that undefined variable explodes. So if you run into that problem, you can do set plus u, and that says turn that option off. So I'll do set -u on the top of my script, and then as I call other things, I'll plus u, minus u around those things as I discover that they're problematic, so that as much of my code is protected as possible. So here, this is not a surprise. We've seen this example before. Now I'm going to start another one. I am going to use a set -u and a -e. So I should actually have put a space here so it's a little clearer. But set u, set e. What does -e do? Well, each line in the script has a final return code. Did this line execute successfully or not? And what -e says is if you complete any lines, and that's not exactly accurate, by the way, don't put me on the word line, but if you complete any lines and you've got an error code as a result, so you might have an error in the middle of the line that pipes and pipes and pipes and it ands and ands and it comes to something good, then it won't be considered an error. But if that line results in an error code, stop immediately. Don't keep going. And so in this case, I am not running a web server on my laptop. So this command fails. And you'll see that the script actually exited. It actually set a return code. I forgot to print that to the screen. But you'll see that word end doesn't appear. And that's because as soon as curl failed, it went ahead and said, stop, don't keep going. Don't keep going if something's gotten screwed up. Just stop immediately. We've probably all instructed people like, if you get to the bank, you've gone too far, go back. This is kind of one of those things. If you had a command and it told you that things are not okay, don't keep going. So this is a good thing. Let's see. And by the way, I just want to show that. So false always returns an error. So if you, here, if I echo, its return code is always an error code. If you have a problem where you actually have something that does in fact have a return code that's an error, you can go ahead and do or true. And this true will clear the error code. So you do the pipe, that stands for the or operator, true. That'll reset the code. So if you have a script where you say you're removing a file that may or may not exist, you can do or true, which says, I don't want to freak out on errors on this line, but for the rest of my script I do. So you can turn it off line by line, or you can use that set -e plus e, set minus e option, but or true is a little more terse. Okay, so now I'm using another thing. I brought this out earlier. The -x shows the command line after it's processed, but before it gets executed. So you will see a globbing operator. A is a globbing operator, so clearly variables are expanded before globbing operators are performed. As you can see, this is actually the command that got run. It's all these files in this directory, and then you can see the output of the actual command itself, and then the end statement. So set -x, I'll put that at the top of my script and then comment it out. And when I'm having problems, I'll turn it back on to see what went wrong. I set an unbound variable. So here A is is set to something, but I used a lowercase a. I made a typo. And so the script explodes because set-u went off. It said you used a variable you hadn't defined. You defined an uppercase a, but you're trying to use a lowercase a. So why am I showing you this example? Because this might happen in production. You might discover it when you run the code, and you might have code paths that are hard to hit. You need a lot of stuff in place to really exercise all your code. So you can use a linter, and there's a linter called shell check. And so I don't know why I'm doing cap shell check up there. Ignore that. This is what I'm trying to cat. But so here's my script, and when I run shell check on the script, it actually kind of does a linting. It says, here are some things that look fishy. It doesn't mean that these are all problems, though some of them are. Like this is clearly a problem. But some of them, like this, says, you might be surprised here. I'm not calling this a problem, but did you really intend this? And so you can see it caught the Globby Operator. So if I was trying to do an ls on a file that actually had the name asterisk, this would go ahead and call that and say, hey, that's not going to work as expected. And you can see it said, hey, your variable is unused, your variable is not set. So this is a great way to just go over your script. Some of them seem like, busy work type items, but if you follow its advice most of the time, you will take care of most of the bugs. So run shell check. It's nice, it's simple. I installed it on my Mac. You can apt-get install it on your Windows box, your Ubuntu box. It's easy to get. Okay, so now, actually here we can see parameter expansion happens before path name expansion. But okay, back to the slides. Okay, so now this is the grand demonstration. Your time is not now. Cron is where a lot of shell scripting problems really rear their head. How many people here have written cron jobs? Okay, hold your hand up if your cron jobs generally run on the first try. Yeah, it's hard. It's really, really hard. Like, it's like sending a file to a friend, right? Like, I don't know, I'll set up an FTP server, right? Like, cron jobs are really hard to do. And they're super hard to debug. Your shell environment, that you develop all your code in this environment, and then cron is like, YOLO, I've got a different environment. And the output, like, who knows where that went, right? Like, if you leave it, like, by default, it'll put it in an email, usually, if you've got your email set up properly so that you can get it. And then, every time your cron prints out hey, everything's A-okay, you get an email, which is often not what you want. You really just want to get an email when things are great. So it can be a real bear. And failures, of course, happen when you're not around to deal with them. We make cron jobs because we don't want to be there when those jobs are running, which means that we don't notice when they fail. Our backup job failed at 3 a.m. 6 months ago, but we just found out now because our hard drive failed. So let's look at some cron jobs, some cron scripts. So here is kind of an example of a fairly boring cron script. Chris, you've seen this before. Well, it falls over sometimes. I wonder if it was busy when it fell over. Well, let's log how many network connections we've got running. How many network connections are on MySQL once a minute. And if it happens to be coincidental that MySQL has a lot of connections and the service just fell over right about then, maybe there's a relationship. So you should have monitoring for these sorts of things, but at 2 in the morning, it's not a time when you want to set up your monitoring system. So you'll hack out a little cron job that says, just keep track of this. If I get woken up again, then I can go ahead and look in it to see if it's my theory of what the cause of the problem was is true. And so here I run the script, and it says I've got 15 established network connections, which I find a little surprising. Okay, so the first thing we want to do is that was just printed to the screen, so that means that would have been stuffed in an email. I want this in a log file, so I can refer to it later. So the exec statement comes in handy. I'm going to lie right now and say exec changes how the current shell behaves. For people who know why that's a lie, we can talk later. For other people who don't know why that's a lie, don't worry, it won't hurt you. So that's what exec is doing, is it's changing how the shell is outputting. And what I'm essentially saying here is from here on out, any output, append it to the log file. And remember, redirect standard error afterwards. So now I'm going to put all of my output in this file. That's convenient because now I can see that log file later on. And so when I run the script, I won't get any output, but when I cat that log file, I can see the output in that log file now. So now that's really helpful because your cron job, you can do just a single redirect, so not an append. That's really awesome. What happened last time? That solves the vast majority of problems. Backup job failed last night. What happened last time? Well, we don't have a log file that will grow forever with that append operator, but we do have that last backup, so we can see, like, oh, were there any errors thrown? So very, very handy habit to have. Put it at the top of your cron job. Put your log file somewhere where you can find it. /temp is good enough. If it's one of those things that you'll look at it when something breaks, /temp is probably good enough to find out. You don't need to keep it around for long enough, just as long as it doesn't get too big. Okay, so the other thing I'm going to do is I'm going to set -e and -u because I don't want this script to kind of limp along. I want it to kind of fail pretty quickly if something goes wrong, so that it's pretty obvious what went wrong and and why. And so I did this -e, -u, and fortunately this script works great. And that's how it is with all cron jobs, right? They just work until you try to use them in cron. And so I get another log line. Okay, cool. So now I have written a fancy cron simulator. And we're going to run that same script again in my cron stimulator. Yes, cron stimulator. Simulator. And now we get an error. And we get BS output too. We get 0. What kind of output is that? Not only do we get output in the file, but we get misleading output. And we get an error message. So what's going on? Well, inside and outside of cron, your path environment variables, I would say may, but are going to be different. Let's face it, they're going to be different. And that causes almost I would say about half my problems, is that it says, I can't find the command you're looking for. And so if you're not aware of it, there's this variable called path, which I showed earlier here, which has these settings, and this is where it's going to look for commands. And so in the case outside of cron, it uses local bin, user bin, user sbin, and sbin. But inside of cron, it's using these directories. And the big thing to know is that user sbin is where netstat is. So it's not going to find that command, it's going to complain the command doesn't exist, and the script's going to, if I didn't have the -e, it would just limp along. But with the -e, no, actually with the -e, it did keep running. Now that I think about it. But it's not clear, it just fails, right? It's not clear why it failed, it just says it can't find the command. So what we can do here is we can change the command we're running. So now I have fully qualified netstats hat. So that way I'm not leaving it up to shell define netstat. I told it where my netstat is. And now when I execute, I get proper output. So that's handy. The problem with this is that you might need to do this a bunch of times. You have a reasonably large shell script running a few commands. You're going to have to do this and find where all the commands are, and it's kind of tedious. So an easier way is just to reset the path. Just find out whatever your path is when you're testing that script, and just stuff it in the top of the script. Now all the commands from then on out will be findable. It's just very easy. It's like -u. It just, from here on out, do the right thing. So very handy, makes it a lot simpler. The script works. Don't know why my network connections are oscillating. And by the way, if you want to simulate Cron, get your pen and paper out. This is what you want to do. M and dash. This says create a new execution environment with nothing. Don't pump any values into it. Don't inherit anything from me. And then the other thing is sh. So that's the command that Cron by default uses to execute your commands. And so use sh and then -c passes the script file name that you're gonna execute. This is not perfect, but this will take care of almost every bug that you might have when you fire it up in Cron. So it'll get you most of the way there. So now let's look at a more kind of realistic cron job. So one thing to note, I commented out the log redirection because I wanted the output to be on the screen so we could see it more easily. And what I'm doing is I'm going to print a value. I'm going to make a temp file like I did earlier. And I'm going to curl something into that temp file. And then I'm going to cat that temp file into this new file because I don't want to screw up the permissions. I'm going to remove my temp file and I'm going to print that file again. And it looks important, right? Pacemaker settings.json. I hope this isn't that important because I didn't run this by the FDA. But what you can see is when we run the script, before the pacemaker is enabled, afterwards, what's the default? Because we don't have any settings. So what happened here? This command failed. And when this command failed, it just kept going. Okay. So let's add the -e. Now when we run, and let's try that again, I guess. Oh yeah, so the command ran here, right, before it got printed out, but when it hit this line, it just stopped. And it actually raised an error code too, so I didn't print the error code. But you notice that line never got run. Before it was run, it had no output. This time it said, okay, I'm just going to stop here with that temp file. And so this never happened, which means that file actually never got overwritten. Which is good, because pacemakers with enabled equals true is probably good. So now here's an even better version of that command. So you notice that when it failed, it just stopped. But I really want to catch that error. Yes, for all the programmers, that means something. I don't want the error to stop. What I want to say is when I get an error, do this instead. And so what I've done is I created a little subroutine called send email. Actually, I probably should not say send email. Sending email / Twitter message. In other words, let somebody know something bad happened. And so just put your code there, whatever you want. And then I'm using this command called trap. And trap is a command that tells the shell when there are certain signals, do something. And a signal is a well-defined thing. So I'm going to not define it and say, when certain events happen, go ahead and run certain things. So in this case, the signal is called error. So it says, hey shell, if you see an error happen, such as when this command causes the shell to, the command fails, and -E causes the whole thing to fail, when you see that happen, run this subroutine before you exit. And so what happens here is that before we have this, and then we print the message, error encountered, sending the message. And for example, you might clean up the temp file, is another thing to put here, so that they don't build up.
So without -E, would the trap only run if the whole script said, say, exit 1? Or will any failing line trigger the trap?
I actually don't recall. I'm not sure. I'll test it in a second, though. And that is it for that example. So, then, I'm done. Any questions?
Well, can I add another error that we'll make? Because I kind of did a similar thing before, but if you go back to your original expansion, echo, when you call echo in bash, for instance, it's not doing the bin/echo, like you think it's actually shell built-in.
Yeah, built in.
Where the echo was broken, so I was getting different results if I called bin echo versus echo, because it turns out there's a bug in one and not the other. So I guess you didn't want to build into that with it.
Yeah. And so, let's see, man bashing, built in. How many people have typed man and then something else into a Google search and just hoped you didn't get the wrong results, if you know what I mean? Google has learned me well enough to know that if I type man, I mean Unix. But yeah, so let's see. Yeah, the point that's being raised is that the shell, here's a description of the double expansion, but let's see. Where's the built-in list? C shell built-in commands below. Built-in commands. Hard to find those. I think they're near the bottom. Well, anyhow, yeah, the shell does some tricky stuff in the back end. And one of those things is echo. It will actually, this trap, ulimit, restricted shell. Yeah, it doesn't have a list of the built-ins. But there's a bunch of commands that the shell will quietly say, I know what you're doing here, I'm just going to do it for you. And the reason why it's doing that is because spinning up processes is actually a fairly involved thing and it's slow. So the shell will say, I'll make, for a lot of common things, I've got little shortcuts that will execute a lot faster. And so those are called built-ins. So if you go ahead and Google bash space built-ins, one word, you'll get a list of all of these. And it's a pretty big list. Almost never does it do anything surprising. But when it does, then never is now. So I would kind of generally ignore it, and I do, but you'll know if you need it. Any other questions or suggestions? You were first.
I think you might have answered this, but have you looked into any other shell scripts, or has Bash been reliable and you've no reason to move on to other things?
I've considered making the move. I played with ZSH for a little while, and boy, the eye candy. But I couldn't get behind it. I've spent a long time as a sysadmin, so I've gotten very comfortable with not getting comfortable. I.e., don't make it my own, use what's there, and get really, really good at it. So I think that there are a lot of shells that are super redeeming. I'm really excited by ZSH. I'm also excited by Conch, which is a Pythonic shell. Yep, Conch, Z-O-N-C-H, I believe it is. And there's Ergonomic, which I just listened to a podcast of a guy who's working on that. I might take a peek at that. It's more Pythonic.
Is it spelled like it sounds?
I think it's Ergonomica is the shell. But look at, I think the podcast is Talk Python to me, and so there are a lot of very good shells, and I would not hold Bash up as the be-all, best, or even best-in-class shell. I actually think PowerShell is frankly quite a bit better than any shell in the Unix world, but that's a different story. It's really a full programming language, but there are lots of shells, and there's good reasons for the diversity. So the talk really focuses on Bash because that's what almost everything is using by default, or Bourne shell. If it's not using Bash, it's using Bourne shell. In almost every example is applicable to Bourne shell as well.
Well, and certainly so many things are direct. Like everybody who wrote the next shell started in Bash for a high degree of neutrality. So most of the things you described feels like either they'll work or they'll be awfully close to what will work in a Bourne shell.
Yeah, and I think Bourne shell is like the de facto standard. So people, if they want their shell to be successful, they know they can double their community if most things generally work. And so there's a real fetishism towards embracing Bourne shell-like syntaxes as a baseline to expand upon. And even in the Pythonic shells, same thing. They really try to make it so you can take a Bourne shell script and just run it in that shell and have it work, which leads to some odd behaviors on occasion, but also means it's more easily accessible by more people. Any other questions or suggestions? So, any other suggestions, questions? Cool. Well, thank you, everyone. I hope you